Major project entitled Experimental Investigation of E-Waste by Partial Replacement of Coarse Aggregate. And the teammates are Sheikh Mohammed SOHAIL, v.dhaval mahendar, Shankar Sai Mohan Ji. Introduction. The project deals with the study of utilization of the electronic waste by partial replaced by the coarse aggregate. The strength test results were compared with those of conventional concrete at 7 and 28 days. The efforts have been made to use the components of the e-waste as a partial replacement of 10 to 12.5 mm the coarse aggregate in the field of construction. Utilization of crusted e-waste materials as a conventional concrete and other materials in the building construction helps in reducing the cost of concrete manufacturing. And it is the most important method to reduce the quantity of the e-waste as well as to achieve an eco-friendly concrete and protecting environment from the effect of pollution. The main source for the e-waste in India is public and private sector institutions which contribute to around 70% of the total e-waste. For solving the disposal of the large amount of the e-waste material, reuse of e-waste in the concrete industry is considered as the most feasible application. And the objective to investigate the potential of e-waste as a partial replacement for the coarse aggregate, to optimize the percentage replacement of coarse aggregate by the e-waste in concrete by conducting tests, to study the effect of M-sand and e-waste on modified concrete, and also to compare the conventional concrete with the e-waste replacement. Scope to check out the experimentally the results for the coarse aggregate which are partially replaced by the industrial waste in the different ratio, to determine the compressive strength, split tensile strength, and compare it with the normal concrete strength without any replacement and without any admixture. Literature review. The Aditya has carried out the experimental work have been made to use the non-biodegradable components of the e-waste as a partial replacement of the coarse aggregate. The effect of work exhibits the good strength in the concrete with 10% replacement of the M20 grade. Ankit Mathur in the year 2017. Population grows by leaps and bounds followed by the industrialization and a dynamic change in the amount of waste generated. These hazardous and other waste pose a great threat to the human health and environment. Tests were conducted to determine the properties of plastic and e-waste as a coarse aggregate such as density, specific gravity, water absorption and compressive strength of the different concrete. Ashwin Manjunath actually he had made an experimental study to made on the utilization of the e-waste particle as fine and coarse aggregate in the concrete with a percentage of replacement ranging from 0 to 30% on the strength criteria of M20 concrete. Compressed strength, tensile strength and flexible strength concrete with and without e-plastic as aggregates was observed which exhibits a good strength. In the present study, compressed strength was investigated for the optimum cement content. Suchitra. Electronic waste is an emerging issue posing serious pollution problems to the human and environment, and the disposal of which is becoming a challenging problem. For solving the disposal of large amount of e-waste material, the use of the e-waste in the concrete is considered as the most feasible application. The replacement of coarse aggregate with e-waste in the range of 0, 5, 10, 15 and 20%. Finally, the mechanical properties and the durability of the concrete mixed specimens improvement in the compressions was achieved in the e-waste concrete compared to the conventional concrete. Sunil Ahirwal. The waste material utilization of the construction industry by products is a sustainable solution to the ecological and environmental problem. Use of such waste materials makes their utilization in the cement concrete. E-waste consists of discarded refrigerators, TV, radios, mobile phones, air conditioners, computers, and several other electronic gadgets. Methodology. The overall methodology has been given below, that is, collection of materials and then preliminary test on materials, mix design calculation, test on fresh concrete, test on hardened concrete, results and discussion, conclusions and references. And this is the collection of materials, that is manufactured sand, Portland, Pozzolan cement, coarse aggregate 10 mm. Electronic waste. Electronic waste described as electrical or electronic devices. E-waste contains the potentially harmful components such as the lead, cadmium, beryllium or brominated flame retardant. Electronic waste or e-waste may also be defined as a discarded computer, office, electronic equipment, entertainment device, electronics mobile phones, television sets, and refrigerators. Preliminary test of the material. The specific gravity and the water absorption test results has been given below. That is, the specific gravity average for the coarse aggregate has 2.7, fine aggregate has 2.7, and for the waste has 1.7. And the water absorption for the coarse aggregate has 0.5%, for the fine aggregate has 0.9%, for the waste has 0.6%. And this is the sieve analysis of the fine aggregate and graph. Overall, the sieve size, that is 4.75, 2.36, 1.18, 500, 300, 150 micrometer, 90 micrometer pan. Overall, the weight, cumulative percentage retained, percentage passing. Overall, percentage weight retained values has been given below. And the above graph shows that the particle size and the percentage finer versus graph. Initial and final setting time of the cement, that is calculated that based on the formula, that is normal consistency, that is equal to 0.85 into P. P stands as standard consistency. The results has initial setting time, that is equal to 32 minutes, final setting time, that is approximately 600 meters. Make design for the M25 grade of concrete. Grade of designation M25, type of cement PPC 43 grade, MSA, that is equal to 20 mm, slum, that is equal to 50 to 75 mm. Specific gravity for the 20 mm is 2.7, 10 mm has 2.7, M sand 2.6, cement 2.8, water 1.0. Mixed design, that is FCK equal to 25 Newton per mm square. Target mean strength, that is equal to FCK plus K into S, that is equal to 31.6 Newton per mm square. Environmental conditions usually moderate. Minimum cement, that is equal to 200 kg. Maximum water cement ratio 0.5 kg. Minimum grade M25, free water 200 kg. Cement content, that is equal to water by water cement ratio, that is equal to 400 kg. PPC, that is equal to 0.1428. Water, that is equal to 0.2 meter cube. Total, that is equal to 0.342 meter square. Absolute volume of aggregate, that is equal to 0.66. 20 mm, that is equal to 0.918. 10 mm 0.70, M sand 1.04. Total, that is equal to 2.658. Weight of the aggregate for the 20 mm has 596.4 kg, 10 mm has 456.04 kg, M sand has 701.6 kg. And water absorption overall value, that is total value, that is equal to 223. Material values has been given below. And overall mix design for the nominal concrete, the above table shows that the per cube how much kg of the quantity we need to use. For the e-waste concrete, for mix design for the 10% replacement of the e-waste, overall values has been given below. And for the mix design for the 20% replacement of the e-waste has been given below. Mix design for the 30% replacement of the e-waste has been given below. And casting of specimen, usually casting of specimen, mixing of specimen, casting of cylinders, casting of cubes, and demolded of specimens. Slum cone test. Slum cone test usually determines the workability or consistency of the concrete, that is based on the construction site during the progress of the work. A concrete is called as workable if it can be easily mixed, placed, and compacted and finished. Proportions of the e-waste and M sand added. For 0%, the slump value is 70. For the 10%, 60. 20%, 55. 30%, 50. 3B consistometer test. The consistency of the concrete is 0.45 seconds for 13.3 and 0.50 seconds for 10.2. Test on hardened concrete. Destructive testing. Compressive test for the conventional concrete. The overall days for the 7 days, 14 days, 21 days, and 28 days. The average compressive strength has been given below. The strength value for the 7 days and 28 days is rapidly higher when compared to the 14 days and 21 days. And this is the e-waste concrete. 10% replacement has been done in the 20 mm aggregate. The strength for the 7 days and 28 days is rapidly higher when compared to the 14 and 21 days. Usually for the 20% replacement, strength value is higher when compared to the 7 days and 28 days. And for the 30% replacement, the compressed strength has been given below. Split tensile strength. For the conventional concrete, the split tensile strength, the average Tensile strength has been given below for the 7 days and 28 days, higher when compared to the 14 and 21 days. For the 10% replacement, the split tensile values is lower, whereas for the 20% has been lower, for the 30% is lower. Non-destructive testing, rebound hammer testing. The compressed strength of the concrete by the rebound hammer is 6.71. Non-destructive testing, ultrasonic pulse velocity stress. Percent of the e-waste used for 10% for the 7 days, 14 days, 28 days values has been given below. For the 20% replacement for the 7 days, 14 days and 28 days value has been given below. This is the comparison of the compressed strength of the conventional concrete for the e-waste concrete. It will show the overall the strength value for the 7 days, 14 days, 21 days and 28 days. This is overall for the compressed strength, whereas this is the comparison of split tensile strength of the conventional concrete for the e-waste. For the 7 days, 14 days, 21 days and 20 days, overall the strength value is determined. Results. It is to be found that the compressed strength for the conventional concrete for the 7, 14 and 28 days is higher when compared to the replacement of the e-waste. Compressed strength for the 10%, 20%, 30% replacement of the e-waste is lower when compared to the conventional concrete. Split tensile strength for the nominal concrete is considerably high when at 7 days and 28 days. Split tensile strength of the cylinder considerably decreases when percentage of the e-waste increases, and also for the 10% replacement of the e-waste strength is considerably high when compared to the 20 and 30% replacement of the e-waste. Discussion. Compression test has been conducted on the specimen and strength of all specimens are above the target stage. Compressed strength of the concrete decreases when replacement percentage increases. By comparing the results with conventional concrete in 28 days results, it is observed that the compressed strength of the concrete is found to be higher when coarse aggregate is replaced by 10%, 20% with the e-waste. More than 10 to 20% replacement of coarse aggregate are not possible used for the construction field because of the strength decrease. Conclusion. Manufactured sand has the similar properties of the natural sand and is the cost efficient than the natural sand. From compression, all specimens tested compressive force above the target strength, that is 68.25 Newton per mm square. By comparing the results with the conventional concrete 28 days strength, it is observed that the compressed strength of the concrete is found to be lesser when coarse aggregate and fine aggregate is replaced by 10 to 20% with e-waste and m-sand. More than 10%, 20% replacement for the coarse aggregate and fine aggregate not considerably used for the construction field because of strength decrease. From this study, we can conclude the use of e-waste in the concrete by replacing the coarse aggregate is possible, but the strength varying occurs. Hence, it solves a potential disposal problem and it saves the natural aggregate. Split tensile strength of the conventional concrete results according to the grade M25. Thus, the environmental effects from the industrial waste can be significantly reduced. And this is the reference, that is Aditya, Ankit Mathur, Ashwini Manjunath, Bal Subran, Nadeem, Praveen A. Manakar, Rafakar, Siddiq, SP Kale, Suchitra and Sunil Ahirwa. Thank you for the